Welcome to the second part of our lesson on order of operations. Just as a reminder, order of operations is simplifying a numerical expression using PEMDAS. That refers to first simplifying expressions in parentheses, then simplifying exponents, followed by expressions involving multiplication and division, and finally addition and subtraction. Another reminder is that absolute value is a number's distance from zero. It is always positive. So if you're taking the absolute value of a positive number, it stays positive. If you're taking the absolute value of a negative number, it becomes positive. All right, let's start with some examples. We're going to use PEMDAS, so I'll just write it up here. Parentheses first, exponents, multiplication and division, followed by addition and subtraction. So let's start with number 13 with our innermost set of parentheses. 7 minus 4. So I'm going to recopy the rest of the problem, simplifying that part first. 7 minus 4 is 3. Okay? So I did my innermost parentheses. Now I see that I still have some square brackets here. I'm going to treat those as parentheses and simplify the expression inside of them next. So to simplify what's inside the red brackets, I'm going to need to start with my order of operations again. I'm going to need to do my exponent first. 3 squared is 9. So I'll get 5 times 9. Now I'm going to handle my simplify the rest of my parentheses here by doing the multiplication of 5 times 9. Okay? Finally, the division, 135 divided by 45, is equal to 3. And that's the answer to this order of operations example. Let's take a look at number 14. I see a quotient, an expression on the top of a rational expression and an expression on the bottom. Let's simplify each separately and then do the division at the end. It's almost as if the top has its own set of parentheses and the bottom has its own set of parentheses. So we'll do them separately. Let's start by simplifying the top. Let's start with our exponent. 2 times 16 minus 8 divided by 2. I'll recopy my denominator. Okay? Continuing to work on the top, I see that I have some multiplication and division. That would be next in the order of operations. So I'll do 2 times 16, which is 32, and 8 divided by 2, which is 4. Copying the bottom again. The top will be 28, and now I can work on simplifying the bottom. I'm going to do my parentheses first, which would give me 7 times 2, 28 divided by 14, and that's going to give me an answer of 2. I'll just restate that. When you have an expression like the one in number 14 that has what looks like a complicated fraction, what we'll call a rational expression, simplify the top first and the bottom separately, and then when you're done, do the division at the very end. Looking at number 15. This one looks pretty complicated too, but we're going to just use our order of operations and chip away at it. Let's start with parentheses. Now recall, as I said, we're going to treat our absolute values like parentheses, our absolute value bars. So let's start with the parentheses around the 8 minus 5. 8 minus 5 is 3, so we'll get 3 cubed minus, now inside of this absolute value bar, we have 2 exponent expressions that are subtracted. So let's use our order of operations and do the exponents first and then subtract the answer. 25 minus 16, and I'll bring down the divided by 3. Okay? Let's continue to simplify this as it is representing a parentheses. So we'll have 3 cubed minus, and in that parentheses, or that absolute value bar, we'll have a 9. Good. Okay? And finally, we'll take that absolute value to get rid of this absolute value bar slash parentheses idea in our mind. 3 cubed minus 9 divided by 3. Okay, We've now finally handled all of our parentheses, including the absolute value bars, which we're treating as parentheses. Now we'll move on to the exponent. 3 cubed is 27. We'll bring down our minus 9 divided by 3. The next thing we'll do is our division here. We're not going to do the subtraction first, the 27 minus 9, because addition and subtraction come after multiplication and division. 27 minus 3 is 24. And that's the answer to example 15. Okay? Again, for number 15, it's important to remember that absolute value bars are going to be treated like parentheses. They need to be addressed first. And within them, you're going to need to use the order of operations to simplify whatever is inside the absolute value bars. So let's take a look at 16. This is putting together some absolute values with another rational expression. As I mentioned in the example 14, make sure that you simplify the top first, the bottom separately, and then do the division afterwards. So let's take a look at 16. Let's simplify the top. We'll start with the innermost parentheses, which are the 9 plus 4 squared. So we'll say 12 times the quantity 30 minus, and in these parentheses we need to start with the exponent because that's going to come before the addition. 9 plus 16. Okay. Now we're going to continue working on the top by simplifying the parentheses that we have here. Innermost parentheses first. So we'll have 12 times 30 minus 25 all over the absolute value of 10 minus the absolute value of negative 6. Okay? Let's simplify further these top brackets. We can do that. 30 minus 25 is 5. So we'll say 12 times 5 over the absolute value of 10 minus the absolute value of negative 6. All right, so now let's take a look at the top. I can finally finish simplifying the top, 60. Now let's take a look at the bottom. Just as we did in our previous lesson, we're going to simplify each of these absolute values separately and then subtract them, okay? So the absolute value of 10 is 10. The absolute value of negative 6 is 6, and they are going to be subtracted. So what we'll get here is 60 divided by 4. And the answer we'll get there is 15. Okay? Now that you've seen me work a few examples, I'd like you to try some practice on order of operations, including these more complex expressions that require you to use PEMDAS and simplifying absolute value expressions.